All right, so today we want to be able to write biconditional statements. Yesterday we talked about inverses, converses, inverses, and contrapositives, and how we went about writing those different things. Today we're going to learn kind of the last one, which are called biconditional statements. Biconditional means you're looking at two statements. We're going to look at the conditional statement, and we're going to look at the converse, and we're going to determine truth values of those to see if we can go ahead and write biconditional statements. So whole goal by the end of the hour is to be able to write these biconditional statements, not only write biconditional statements from a conditional statement, but if you're given a biconditional statement, be able to break it up into kind of its two pieces that it belongs to. Kind of a long definition of what a biconditional statement is. Yep, I would. A biconditional statement. A conditional statements and its converses. Or it says there's an if out in front of there that you can't see on the screen. It says if a conditional statement and its converse are both true. So if a conditional statement and the converses are both true. So that's the first piece of it. We have to put a truth value to both the conditional statement and its converse. So we worked on writing the converse from the conditional statement yesterday. You've got to be able to do that part. Second thing we have to do is we have to put truth values to them. Are they true? Is the conditional statement true? And is the converse true? If both of them are true, then the two statements can be combined and written as one, what we call biconditional statement. So if the conditional statement is true, the converse is true, then we can combine those two and write them as what we call a biconditional statements. Biconditional statements are written in the form P if and only if Q, or Q if and only if P. Now remember, P is our hypothesis, Q is our conclusion. So we can write the statements in one of two ways, if they're both true. P if and only if Q, or Q if and only if P. You don't write anything after that. Okay, just stop there. The rest of it's just notes that you really don't need for your purposes. Okay, so we can write them in two ways once we've determined their truth value. P if and only if Q, so your hypothesis, if and only if your conclusion, or you can turn it around. It doesn't matter. Now, because we're math people and we hate writing stuff, we use shorthand. The phrase if and only if is often shortened to IFF. So you'll see me put IFF instead of if and only if. It's just too much writing. So if you see IFF mathematically wise means if and only if statements. Another way, the symbols for biconditional statements, you'll see instead of the P and then an arrow to Q, you'll see kind of that double arrow. And both of those statements simply mean you can replace the double arrow with if and only if, P if and only if Q, or Q if and only if P. And really, when you're writing really good definitions, really good definitions in mathematics are written as biconditional statements. This happens if and only if this happens. An angle is acute if and only if it is less than 90 degrees. An angle is obtuse if and only if it is greater than 90 degrees. An isosceles triangle. A triangle is isosceles if and only if it has at least two congruent sides. Okay, so really good definitions are really written as biconditional statements. Okay? Any questions so far? Need a couple more seconds? Just give you a couple more seconds. And again, after this piece here, the rest of it, Just symbols. Okay, so there's our definition of what a biconditional statement is. Now what we want to do is we want to be able to practice it. So here's our conditional statement. This is our conditional statement. If a triangle is a right triangle, or if a triangle is a right triangle, then it has one right angle. So that's our conditional statement. Give you a couple seconds to write that down. If a triangle is a right triangle, then it has one right angle. That's our if this happens, then that happens. Our hypothesis is it's a right triangle. The conclusion, it has one right angle. So we've got our p value and we've got our q value. So the first thing we need to do is we need to determine if that statement is true or false. So if we think about it, if a triangle has one right angle, so it has one 90-degree angle, is that a right angle? Yeah. Okay, so that's a true statement. So the conditional statement is true. Okay, so that's the first thing we need to determine. Is it true? We know that's true, and that is about as good a circle as you get. Okay? So now what I want you to do, from what we worked on yesterday, write the converse of that. What's the converse of that look like?
What's converse?
Remember, the converse switches the hypothesis and the conclusion. So what was the hypothesis becomes the conclusion, and what was the conclusion becomes the hypothesis. So our hypothesis, or our Q value, our P value, is right there. Our Q value is right there. And remember, the converse flips those two around. So go ahead and write the converse of that statement. Come on, guys. Okay, so what's the converse? If a triangle has what? One right angle, then that is a right triangle. Okay? Converse is if a triangle has one right angle, then it's a right triangle. Okay? Flips the hypothesis and the conclusion. So our goal is to write it as a biconditional statement. So we have to figure out the truth value of the converse as well. So if a triangle has one right angle, then it's a right triangle. That's a true statement. Okay, so I have a true statement. So then the next question that we ask, are both the conditional and the converse true? Well, we said they were. So the answer to that is obviously yes. They are both true. If yes, then we can write the biconditional statement. So since both the converse and the conditional statement were true, we can write this as an if and only if statement. And this is what it looks like as a biconditional. A triangle is a right triangle, IFF, if and only if it has one right angle. So that's our biconditional statement, one of the biconditional statements. That one was P if and only if Q. So a triangle is a right triangle if and only if it has one right angle. So you take your conditional statement, make it sound good, and put if and only if in the middle of it. Or, remember from the definition, not only is P if and only if Q, but it's also Q if and only if P. So we could write it the other direction. A triangle has one right angle if and only if it's a right triangle. So it can be written either way. It doesn't really matter. But again, in order to write the biconditional statement, the conditional statement has to be true. The converse has to be true. When both of them are true, we can write the biconditional statement. If they're not true, you can't write it. And you simply can't write it if one of them's not true. You just simply say, it's not a biconditional statement. I can't rewrite this as a biconditional statement. Any questions with that first example? Okay, so let's look at the next one. So here's our statement, our conditional statement. Make it shorter so it's not as much writing. If the measure of angle A is 33 degrees, then angle A is acute. So yes, this does require you to know some definitions in geometry. You have to know what acute means. You have to know what 33 degrees is. The things we've talked about already. So we need to determine if that's true or false. Is that statement true or false? It's true. All angles less than 90 degrees are acute. So that's a true statement. Okay? And I could circle true or whatever. So it's true. I may have done this in the PowerPoint, I don't remember. Okay, go ahead and write the converse to that. Write the converse to that statement. Write the converse. So what's the converse? If angle A is acute, then its measure is 33 degrees. Oh, I did circle that. Okay, so there's my converse. If angle A is acute, then the measure of angle A, I just forgot, then the measure of angle A is 33 degrees. Is that true or false? Are there any, remember, in order to prove something false, one counterexample is all you need. Is a 45-degree angle acute? Yes. Okay, so this says if it's acute, it has to be 33 degrees. Does it have to be 33 degrees? No. So this is false. Okay, so that's a false statement. So then because that statement is false, are both conditional and converse is true? Obviously that's no. So since that answer is no, you cannot write this as a biconditional statement. You're simply done. It can't be written as a biconditional. In order to be written as a biconditional, they both have to be true. If they're not both true, you can't do it. Okay? No ifs, ands, or thens about it. You can't write a biconditional statement. They both have to be true. Okay? So let's try one on your own. Here's our statement. If an angle is obtuse, then its measure is greater than 90. If an angle is obtuse, then its measure is greater than 90. So there's our conditional statement. I want you to write the converse to it. Give both of them truth values. Are they true or false? And then if they're both true, write the biconditional statement. So write the converse, determine if they're both true or false. If they're both true, write the biconditional statement. Chances are pretty good, if we're working on writing biconditional statements, that I probably want you to write one of them. And some of you can just do these in your heads pretty quickly. About another minute. So just write one biconditional statement. You don't need to write one. Just write one. So the converse you should have had, if the measure of an angle is greater than 90 degrees, then it's obtuse. So those are our statements. Are they both true? Yeah. They're both true. Conditional statement is true. Converse is true. Therefore, we can write the biconditional statement. An angle is obtuse if and only if its measure is greater than 90 degrees. Or you could have written, if an angle's measure is greater than 90 degrees, then it's an obtuse angle. Try it again. An angle greater than 90 degrees is if an angle measured greater than 90 degrees is obtuse. Yeah, right. Okay. I can't write that one for some reason. Why can't I write it in reverse? The measure of an angle is greater than 90 degrees if and only if it is obtuse. There it is. That's way too much wording. Again. Math teacher. Oh, that's funny. All right. So, now that we can take it in one direction, we can write a biconditional statement. Now let's go the other way. Say that you're given a biconditional statement. So now we're given a biconditional statement, and we want to write both the conditional statement and the converse. So now you're given, this is a biconditional statement. Angle 1 and angle 2 are vertical angles if and only if angle 1 and angle 2 are congruent. That's our biconditional statement that I'm saying is a biconditional statement. What we want to do now is we want to go the opposite direction with this. We want to take this biconditional statement and we want to write the conditional statement and we want to write the converse of that. Okay, so if we think about what's our hypothesis and what's our conclusion. Angle 1 and angle 2 are vertical angles. That's our P. They're congruent. That's our Q. So if we're writing the conditional statement, the conditional statement to that would be if angle 1 and angle 2 are vertical angles, then angle 1 and angle 2 are congruent to each other. Okay, so I just took it from a biconditional and wrote it as a conditional statement. Remember, all conditional statements are if-then. If this happens, then that happens. Okay. Now that we have it as a conditional statement, we can write the converse of it. Again, we said this was our P value, and that was our Q value. So remember, the converse just flips the P and the Q. So the converse to this is if angle 1 and angle 2 are congruent, then angle 1 and angle 2 are vertical angles. So we've got this biconditional statement that's out there. We can change it into a conditional statement and its converse. Is this a valid biconditional statement? In order for it to be a valid biconditional statement, both of these have to be true. The first one angle 1 and angle 2 are vertical angles, then they're congruent. That's true. Okay, vertical angles are congruent to each other. The second one says, if angle 1 and angle 2 are congruent, then they're vertical angles. Could I have two angles that are congruent that are not vertical? Sure. Sure. I mean, I could have a 90-degree angle over here and a 90-degree angle over here. They're not vertical angles. So this biconditional statement is actually not something that can be written. Okay? So you have to look at the biconditional statements that you're writing, the biconditional statements today that they give you, and determine if they're even valid biconditional statements, because sometimes they're not. And this, in this case, this is not a valid biconditional statement. Okay, if we take a look at this one, there's my biconditional statement. The sun is out if and only if I get a sunburn. So I want you to write the conditional statement to that. I want you to write the converse to that, and then determine the validity of that biconditional. Is it truly a biconditional statement? So write the conditional statement, write the converse, and tell me if it's valid or not. So again, you're writing the conditional statement. From that biconditional, you're writing the converse, and then you're determining the validity of it. Is that actually a valid biconditional statement? About 30 more seconds. It's a pretty short one. So the conditional statement, how I wrote it, if the sun is out, then you could get a sunburn. I put the word could in there. I don't know. Is that true? That you could get a sunburn?
Yeah.
Yeah, that's true. I mean, you could get a sunburn. That's why I put could in there. Some people don't burn, which is bad. I don't burn, which is bad. True or false? Obviously, that's true. The converse of it. If I get a sunburn, then the sun is out. If you've ever been in Florida or south of Florida or up in the mountains, the sun's not out, you still get a sunburn. Sun's behind clouds, the UV's so high, you still get a sunburn, even if the sun's not out. Okay, so that's actually a false statement. Okay, so since that's a false statement, then is it a valid biconditional statement?
No.
No. So what you're going to do today, you got two parts to your assignment today. You're only going to do the first 6 questions on the worksheet, or if you're going to look side Schoology. First part of it, you're going to write the converse, the inverse. They'll give you the conditional statement or the converse. You have to write the other one, determine the validity of it, and then if they're both true, write the biconditional statement. That's the first 3 questions. The second 3 questions give you the biconditional statement, and you need to write the converse and the inverse and figure out its validity. Okay? If you want the worksheet is right here. If you want to do it off of Schoology, the worksheet is already in there. You only have to do questions 1 through 6. Okay?